So in this case, how we gonna solve this problem? This problem is saying that drive an expression for CGD, use the Miller theorem and Miller approximation. So in this case, we have to draw a small signal model, and in the first, I think we're gonna ignore the channel length modulation on there. And second thing, first we're gonna draw the small signal model for this circuit. And in this case, we weren't gonna use any kind of capacitor. First, we're gonna figure out what is the gain value, and after that, we're gonna use the Miller theorem to figure out what is the Miller approximation in this circuit. So first, we're gonna draw all kind of independent source will be in the ground, and this is the VG. GM VGS on there, and this will be the VS, and which is kind of the RS right there. Okay, so if we do that, and that will be the V out on there as the V in. So first equation, I know that the VG equal to V in. This is with the VS right there. And so second equation, we can write it down the KCL over here, V out over RD plus GM VGS equal to 0. The second equation, this is the first equation. Third equation will be the VS over RS minus GM VGS equal to 0. So if we analyze this over here, and we'll got the AV is the gain value, negative GM, we'll get the negative GM RD and 1 plus GM RS. So after we got the gain value on this circuit, now we're gonna do the Miller approximation. And the Miller approximation says that if that I have two voltage one there, and then we're gonna split it to capacitor. So V2, so V1, V1, there's V2 on there. So it's gonna be C is the 1 minus AV, and C 1 minus 1 over AV. So, and we have to redraw our circuit again for the Miller approximation. So in this case, we're gonna draw it look like that. This is the V in. That will be the C is 1 minus AV, and that will be another voltage right there, and the capacitor right there is gonna be C 1 minus 1 over AV. After that, we're gonna draw the same thing what we draw it in before the small signal model. VGS, and come over here for the RD. Another one is the RS right here. That will be the small signal model for this Miller approximation. So in this case, if we want to figure out what is the capacitor value on this, the CGD1, so we're gonna write down look like that way. If we find out what is the tau 1 value on there, so it's gonna be tau 1, tau CGD. That's called the CGD input value, because the V in over here, this is the V input over here. So CGD input, and that will be the CGD output. So if I figure out the CGD input value, is gonna be the CGD1. So which I wrote it down the C on there. So it's kind of easy to calculate. So CGD1 over here. I think it's the same. The CGD1 and CGD2 are same. So I write it down the CGD. It's the 1 minus, what do you get? That's a negative GM RD plus GM RD 1 plus GM RS. And because that have a one resistor on there, so we're gonna write it down, multiply RG. And if you want to figure out the output, the tau CGD output value, we're gonna do same thing over here. CGD 1 minus is a 1 over GMRD 1 plus GMRS into, because the CGD output over here, because this is the V output over here. So our R value will be the RD. So we can say the CGD 1 minus 1 plus gm rs gm rd negative one there, so negative positive over here into rd. This is for the Miller approximation. Thank you.